Hello friends. In this video, we are going to study about the types of architectures in the embedded systems. There are various types of architecture supported in embedded system like von Neumann and Harvard architecture, syst architecture and RISC architecture. So we will study about these types of architecture, what is the configuration of the embedded system in these types, and we will see the comparison between these architectures also. So let's start with our topic. Let us first understand that what is an embedded system. The word embedded means that something is attached to another thing. Okay, so we can thought the embedded system as a computer hardware in which the software is embedded in it. Okay, so an embedded system, it will consist of an hardware part and a software part. Okay, so we can say that the two main parts of the embedded system are the embedded hardware and embedded software. So in any embedded system, there will be two main parts, the hardware and software. Now the hardware part, it will consist of the processor, memory, bus interface, peripheral devices like the input devices and the output devices, input output ports will be there, and various controllers will be present in it. So in the hardware part, it will consist of these components. Now in software, it will consist of the operating system, and various applications. Okay, so if we see the basic architecture of an embedded system, then it will consist of two components. The two parts will be there, embedded hardware and embedded software. The hardware part, it will consist of processor, memory, bus interface, peripheral devices, input output ports and controllers. That is the physical part of the system. And the embedded software, it will consist of the operating systems and the applications. So if we draw the basic architecture of an embedded system, then it will have in the software part, we are having applications and embedded operating system. In hardware, we are having the embedded processor, and peripheral devices, and many other components can also be present in it. So this is the software, this is the hardware, and this whole system is contained in the embedded system. Now to the embedded system, we will have an input and an output. Just like in a computer system, we are having the input and the output. So in the embedded system also, we will have the input and output. Now the hardware and the software part of the embedded system, that will be dealing with the input and the output. Okay, it will be getting the input signals from the devices like the keyboard and the other input devices like the mouse and there. So with the help of these input devices, either it will be getting the input, or from the other system it is getting the input signal. Okay, and then these input signals, they will be processed, and according to that the result or output will be generated. Okay, so hardware and software, it is dealing with the input signals, doing the processing over it, and then generating the output. So that is the main function of the embedded system. Now, as I have said that in the embedded system we are having the hardware part, and in the hardware we are having the microprocessors or the processor. Okay, so processor is the main part of the embedded system because it is doing all the processing over the data. So embedded system, it will have processor. Generally, the microprocessors are used in the embedded systems. Microcontrollers can also be used. So the function of the processor is to control the computer operations, execute the instructions, and process the data. So it is going to perform these functions. Another part or another component in the hardware is the memory. Memory is used to store the instructions and the data. Then it is having the input output modules or input output devices are there. So these input output devices, they are responsible for the exchange of the data, or we can say for the communication of the system with the other devices. So input output modules, they are. Then we are having the bus system. This bus system, it provides the data and the addresses for the memory, and also it is going to provide the timing and the control signals. So this provide data, bus system. So we can say that the basic architecture of the embedded system, it consists of hardware, software. In hardware, we are having the processor, memory, and input output system is there. The bus system is there. Okay. So the function of these components we have discussed here, that what a processor does, what memory and input output modules and bus systems are going to perform, or how they are working in the system. Okay, so this is the basic architecture of an embedded system. Now, this architecture in the embedded system, it is divided into two types. Okay, one is the von Neumann architecture and other is the Harvard architecture. Okay, so let's see the that what is the configuration of the system in these two types of architectures and what is the difference between them. So basically there are two types of architectures. Von Neumann and Harvard. These architectures are named after the scientists who developed them. Okay, so first we will start with the von Neumann architecture. So this von Neumann architecture, it was first proposed by the scientist Neumann. So it is named after the scientist who proposed it. Now, in this architecture, the main feature of this architecture is that the software and data, they use the same memory. We know that the memory is used to store the data and the programs and instructions of the processor. Okay, so in the von Neumann architecture, the software, that is the programs and the data, they are going to use the same memory. So in the same memory they will be stored. Okay. So because the softwares, that is programs and instructions, they are also stored in the same memory and data is also stored in that memory. So if the processor wants to if he wants to have the data, so that data will be transported or it will be given or transferred to the processor with the help of the system buses. Okay, so buses will act as a communication link between them. So data is also transferred through the same system bus, and instructions and programs, they are also going to be transferred through the same system bus. Okay, so an instruction and data, it share the same system bus in the von Neumann architecture. Okay, now because they are using the same system bus, so that is also going to create the problem. Okay, because at one time either the data can be transmitted or the instruction can be transmitted. So we can say that a data operation or an instruction, they cannot be executed at the same time. Okay, so because on the same system bus we are having the instructions also and we are having the data also, so that is going to create a bottleneck of transmission. Okay, the problem or congestion or a problematic situation will be created that either the instruction or data will be executed. So that is becomes a bottleneck of computer performance and affects the speed of processing. So because sharing of bus is to be done, okay, same bus is to be used for data and instruction, so transmission of information, it becomes a bottleneck of the computer performance is going to be degraded, and also it is going to affect the speed of processing. Okay, because only one operation can be done at a time. So at one time only one operation will be performed, means either the instruction will be fetched from the memory or data will be fetched from the memory. So we can say that the data operations and instruction fetching cannot be done at the same time. So we can say that this von Neumann architecture, it supports the simple hardware, okay, and it supports the use of a single sequential memory. Single means only one memory is there for the data and instruction, and sequential means that in a sequence either the data or instruction that will be transferred to the processor. Now, if we see the architecture of the system in the von Neumann type, then it will have the memory. So there is a single memory space, and this memory is divided into the program ROM and RAM. RAM is divided into variable RAM and for the stack, okay, and data is can be transmitted or it can be stored and retrieved from the memory. Addresses is to be given and the control instructions or control signals are to be given. Then we are having the memory interface unit, okay. This interface unit is going to communicate between the processor and the memory. Also, it is connected with the instruction decoder, which is decoding the instructions and then they are executed. Okay, so here you can see that it is having only a single memory space for the data also and for the instructions also. Okay, so this von Neumann architecture, in this architecture, the system data and the instructions, they are sharing the same memory, same system buses to be shared. So that is going to reduce the speed of processing of the system and also the performance of the system will be reduced. Now the second type of architecture is the Harvard architecture. This architecture was proposed by Howard Mark, so it is named after the scientist who proposed it. Now, in this Harvard architecture, there is separate memory for the instructions and for the data. So, the difference between von Neumann and the Harvard architecture is that in von Neumann architecture, there was only a single memory which is shared between the instructions and program and the data, whereas in the Harvard architecture there is a separate memory for the instructions and for the data. So here in this Harvard architecture, the instructions and data, they are stored in two separate memory modules. So they do not coexist in the memory. Okay, separate memories are there for instructions and for the data. Also in the Harvard architecture, because the instructions and data, they are stored in different memories, so if the processor wants to execute the instructions or if you want to execute the data, then there are two separate buses for the instructions and for the data. Individually they will be having separate system buses. Okay, so there are two independent buses used as So there are two independent buses which are used as the dedicated communication paths between the CPU, that is the processor, and the memory. Independent means that there is no connection between the two buses. Okay, for the instruction there will be a separate bus, and for the data there will be a separate bus. So if we see the Harvard architecture, if we see its diagram, so this is the Harvard architecture. In this you can see CPU. It consists of the instruction register, controller, data channel, which is input and output. Okay, this is the part of the CPU. Now this CPU can interact, that is processor, it can interact with the program memory and with the data memory. You can see there are separate memories for the instruction and for the data. So address is being given by the CPU, that which instruction it wants to execute, and then that instruction will be sent to the processor. Similarly, for the data memory, it is going to send the address, that from which memory address the data is to be picked, and then that data will be sent to the processor. So Harvard architecture is having separate memories for the program and data, whereas in von Neumann architecture there is a single memory which is being shared by the program and the data. Now, as in the Harvard architecture, because there are separate memories, so the speed of processing will be fast. So, in this Harvard architecture, because the data memory and the program memory, they are separate, so it is providing greater data memory bandwidth. Okay. Also, speed of processing is fast because the operations which are related with data and the operations which are related with the instructions, they can be done at the same time. Okay, means data operation and instruction execution, it can be done at the same time because there are separate buses for them. Also, because speed of processing is fast, so performance of the system is being good. Okay, it is being improved. So these are the advantages of the Harvard architecture. Now, let's see the comparison between the von Neumann and the Harvard architecture. Okay. So first difference will be that in von Neumann, single memory is shared between data and instruction. In Harvard, there are separate memories. Now in the von Neumann architecture, if the processor it wants to fetch the instruction, then it has to use a separate clock cycle. If it wants to fetch the data, then it has to use the separate cycle for that. Okay, so processor needs to fetch So to fetch the instruction, there will be a separate clock cycle. To fetch the data, there will be a separate clock cycle. Okay, it has to use another clock cycle for that. So it requires two clock cycle for the data and for the instruction. Whereas in the Harvard architecture, single clock cycle can be used to fetch the data as well as the instruction or the code. Now in von Neumann architecture, because they are simple in design, whereas Harvard architecture, they are complex in their design. Because here same structure, same memory can be used by both. Okay, so circuitry is being reduced, whereas in Harvard there are separate memories, so circuitry is more. Okay, so here less circuitry means they are simple in design, and more circuits means that it is complex in design. Also the von Neumann architecture, they are very fast in their processing. Okay. So von Neumann architecture, it consumes less time, whereas Harvard architecture, it consumes more time. So this is the comparison between the two types of architecture, von Neumann and Harvard architecture, which are based on the fact that whether the data and the program memory, they are available as a separate units or as one single unit. Okay. Now in embedded system, there are also the second type of architectures. Okay, the first classification of the architecture or the first type of architecture we have seen that it is on the basis of the program memory and the data memory. Second type of architectures, they are classified on the basis that whether the instructions are complex, means the instruction set of the system of or the processor, that is having complex instructions or simple instructions are present in it. Okay, so second classification or second types of architecture are the syst and the risk architecture. In embedded systems, we have the processor. Okay, so processor can have the syst or the risk type of architecture. Okay, so syst means that complex instruction set computer, and risk means reduced instruction set computer. Okay, so in the complex instruction set computer, there are complex instructions. Okay, the instructions which are available in the instruction set, they are complex instructions. Also the number of instructions present will be more in it. Okay, so we can say that large number of instructions are there. Okay, now if there are complex instructions, so it will be very difficult for the user to understand those instructions. Okay, and also that will be difficult for the processor to execute them. Now in the reduced instruction set computers, there are simple instructions which can be easily remembered or used by the users. Okay, and also the number of instructions produced, that will be less. So that is the main difference between the syst and the RISC architecture. Okay. In the syst architecture, we are having complex instructions and large number of instructions are present there. And in the reduced instruction set computer, there are less number of instructions. Simple instructions are there, so they can be easily executed. Now let's study some of the points of differences between the syst and the RISC architecture. So in syst there are larger set of instructions. In RISC there are smaller set of instructions. In syst there is simple design of compiler. In RISC architecture there is complex design of the compiler. Now in the CISC architecture, there are many addressing modes, okay? Because the number of instructions is also more, so addressing modes will be more, causing the instruction format to be complex, okay? Whereas in the RISC architecture, because very less number of instructions are present, so very few addressing modes are there, and also the instruction format is fixed in it, okay? Whereas in this instruction length is fixed. Now in six architecture, the higher clock cycles per second, because the instructions are very complex. So to execute those instructions, more number of clock cycles will be required. Whereas in the RISC architecture, low clock cycles per second. In the CISC architecture, the emphasis is made on the hardware. That what are the hardware components involved in the system, whereas in the RISC architecture the emphasis is on software. In the CISC architecture, the control unit implements the large instruction set using the microprogram unit, okay? Whereas in the RISC architecture, each instruction is to be executed by hardware. Here control unit is going to implement the instruction, whereas in the RISC architecture, each instruction is executed by the hardware. Also, in the RISC architecture, the execution is slow, okay? Whereas in the RISC architecture, there is a faster execution, because each is to be executed by the hardware, okay? So in the syst architecture, there is slow execution because the instruction has to be first fetched and then executed by the control unit. Whereas in the RISC architecture, because each instruction is individually executed by the hardware, so faster execution is there. Also, in the syst architecture, pipelining is not possible. Whereas in the RISC architecture, the pipelining is possible. Okay. So these are the differences between the SISC and the RISC architecture. Okay. So here in this video, we studied about the types of architecture in the embedded system. We saw that the architecture in the embedded system, it can be classified as either von Neumann or Harvard architecture, or the architecture can be classified as the RISC or the SISC architecture. We studied about these architectures in details, and we also saw the comparison between these architecture, that what is the difference between von Neumann and Harvard and between the RISC and the SISC architecture. So in the embedded system, we are having the main part as the processor, okay, or we can say the CPU, the main part of the embedded system which is doing the processing. So that processor can either be present, the components, the various components of the processor, they can either be present in the von Neumann and Harvard architecture, or the processor can be of CISC or the RISC type of architecture. Okay, so I hope that this topic is now clear to you. Thank you.